Hello and welcome back. Welcome to the video lecture on math and symbols, at least our first one. So this corresponds to section 2.2 in your textbook, and there really are only two goals to the section. And both may be reviewed for some of you, but it's important to make sure everyone's on the same page. So first is order of operations. I'm going to assume you already know this from high school math, but Field gives us a couple of acronyms to help us remember. I prefer PEMDAS to BODMAS because, to me, it makes more sense. The words are more intuitive. So PEMDAS means parentheses or brackets, exponents, powers. MD is for multiplication and division. A and S is for addition and subtraction. So you start with the brackets, you move to the exponents, any multiplication operations, because division is simply another kind of multiplication in a sense. Same with addition and subtraction. You can convert the one to the other. Hopefully that's review. The second section is more likely to be new to you. All types of mathematicians like to use Greek letters and formulas. There are many reasons for this, including that Greeks were responsible for many of the early advances in math. Also, if everyone uses Greek letters to mean the same thing, then math and statistics can be communicated across language barriers. For now, the only Greek you need to know is this. It's a sigma. It's a capital sigma. It will always mean the sum of whatever comes after it. So if we write sigma 1, 2, this equals 3. It's the sum of 1 and 2. This would not be very useful by itself, though. Where the notation becomes more useful is if you'd like to add a series of values together. For this, we need two additional pieces of notation. First, we need the subscript I. This I, a subscripted lowercase I, refers to one element of a series by its position in the order, or the ith value you can think of. So x sub I is the value of x for the ith case. We've got some sample data up here. So in this case, we're using xi equals 2i. So for I equals 1, x would equal 2. For the second case, x would equal 4. For the third case, x would equal 6. Remember that I is just a stand-in for the case order. Usually I is not terribly important in this. I'm just using it for an example here. So what if we wanted to, instead of the sum of 1 and 2, we wanted the sum of xi, but we need to know for what x. That's the second piece of notation we need to add. So under this sum, you'll usually see something like I equals 1, and then a number up here. In this case, we'll say 4. If it's cases in a data set, instead of a 4 here, you would likely instead have n, meaning this is read as the sum of x sub I from I equals 1 to n. So it's x sub 1 plus x sub 2 plus x sub 3 all the way until x sub n. If n is 1300, then you would add together the first 1300 values of x. You can see how this would be much more useful than writing out the sum of 1, 2, 3, 4, etc. Now, before we leave, we need one more reminder. You need to be careful when summarizing across cases to differentiate between quantities inside and outside the sum and follow your order of operations. So imagine we have sigma xi squared from I equals 1 to 4. This quantity here, if xi is 2i, then we would add together this whole column and we would get equals 4 plus 16 plus 36 plus 64 equals 120. If instead we did the same thing, sum from I equals 1 to 4 of xi, but we square here, this is something different. This means we add together all the xi, 2 plus 4 plus 6 plus 8, is going to equal 20. So that equals 20 squared, which equals 400. Hopefully that makes sense. Just remember, sigma means sum, I refers to the case in order, this from I equals 1 to whatever the number is, or to an n, tells you how many cases and which ones to summarize over. And we have to remember order of operations, both when we're using sigmas and in other formulas. So to review, we talked about order of operations, why it matters. We introduced the statistical notation for summarizing across cases. Next up will be measurement, error, validity, and reliability. In the meantime, thanks for watching.